The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, in a little bit, we're going to go on to section 7.7, which is the last section we're going to cover in chapter 7. And so tonight's homework will be the 7.7 as well as the chapter review. Tomorrow we'll review, and then let's see, today is Tuesday, right? So then Thursday we'll have the chapter 7 test. But before we do that, do you have any questions you'd like me to look at from previous assignments?
I guess tonight's homework, question 16 on mine. I have like 5 questions that I couldn't get.
Okay. Do you want me to pull them up on WebAssign, or do you want to just tell me what they are?
Do you want to just pull them up since those are the only ones I have left? Since
okay, we can take a look at that. All righty. Just a minute here. Okay. So this is from 7.6.
Yes.
All righty. And let's see here. So starting with problem number 16. Okay. So this is 7.6, number 16, and we'll look at it in WebAssign. All right, so it says, solve the formula for the indicated variable. We have 1 over x minus 1 over y equals 1 over z, and we are to solve for y. Okay? So y is in the denominator. What I'm going to do is I'm going to multiply both sides of the equation by the LCD, which would be x, y, z. Okay, so distributing, I'm going to get x, y, z times 1 over x minus x, y, z times 1 over y equals x, y, z times 1 over z. Any questions about that?
No.
All right, going through and simplifying, the x's will reduce out here, giving me yz, minus the y's will reduce out there, giving me xz, equals the z's reduce out here, giving me xy. All right, we're trying to solve for y, and these two terms have y, and this term does not. So what I'm going to do, I'm gonna let's see here. I'm going to subtract xy from both sides. So I get yz minus xy minus xz equals 0. Then I'm going to add xz to both sides. So what I end up with then is yz minus xy equals xz. Okay, so I have the two terms that contain the variable y on the same side of the equation, and the one term that does not contain y on the other side of the equation. Now I'm going to factor a y out of the left-hand side. So now I have y times a quantity. Then I will divide both sides by that quantity, giving me y equals xz over the quantity z minus x. Okay with that?
Yes, I did a different method. That's why I was like totally confused. I did
Yeah,
it similar to yesterday's homework to try to get YZ and I could not get it.
do you follow what I did here?
Yes.
Okay, okay. And on yesterday's video, if you look back at it, you'll see I did do a problem like this, but anyway. Okay, so back to the web assignment, assignment. It looks like, did you need me to go over 17 or 18? Looks like you've got those fine.
Number 19, I had a little bit of trouble.
Okay, let's take a look at 19. Okay. Solve the formula for the indicated variable. So 1 over A plus 2 over B equals 1. And we are to solve for A. All right. So let's go back to the whiteboard screen. So again, I'm going to multiply both sides by the LCD, which is AB. I'm going to distribute. So I've got AB times 1 over A plus AB times 2 over B equals AB times 1. Okay. Next, I'm going to go through and reduce. The A's reduce out, and I've got B plus the B's reduce out. 2A equals AB. Okay.
Yep.
I have 3 terms, 2 of which have A in it, 1 of them doesn't. Put all the terms with A on one side of the equation. So I'm going to subtract 2A from both sides. So B equals AB minus 2A. Then I'm going to factor out an A on the right-hand side. Divide both sides by what's left. And I get A equals B over B minus 2. So really, this is exactly like the previous problem, just that there were more variables involved.
See, what I did was since I have AB on one side, on the right side, I just divided it by B to get B plus 2A over B.
Hang on here. So you're talking about right here or here?
One more down, right there.
Right there.
So
Okay,
since I have AB already on one side, I just divided by B to get B plus 2A over B.
Okay, and then what?
I stayed there.
But the problem is you then have A on both sides of the equation, so you haven't solved for A.
Okay.
Yeah, really, the only way to deal with this is to factor that A out of the 2 terms. Otherwise, you just kind of go around in a circle.
Okay. I think now I know what I'm doing wrong with the rest of them.
Okay, do you want me to do any others?
You have like 20 and 22 and 26.
Okay, 20 is again going to be the exact same thing, but let's take a look. We have 16 over A minus 16 over B equals 16, and we are to solve for B. Okay? So I'm going to multiply both sides by AB. Distributing, I'm going to get AB times 16 over A minus AB times 16 over B equals AB times 16. All right with that?
Yep.
Going to go through and reduce out the A's, and I have 16B minus, reduce out the B's, 16A equals 16AB. Since I'm trying to solve for B, I'll get all the terms with B on the same side of the equation. So I'm going to subtract 16B from both sides, giving me negative 16A equals 16AB minus 16B. Then I'm going to factor B out of the right-hand side, giving me 16A minus 16. Okay. Divide both sides by 16A minus 16. So I get b equals negative 16a over 16a minus 16, but I can factor a 16 out and get, in fact, let's do this. Let's factor out a negative 16. So then I get negative a plus 1. So b equals a over, and I'm going to write it like that. Just switch it around. I could have written negative a plus 1, but do you follow what I did there?
I believe so.
Do I need to go back over something a little slower maybe?
Where did you minus this? Oh, 6. Okay, I see it now.
This is again pretty much like the previous two, except then there was that factor of a 16 or a negative 16 that we could reduce out.
Mm-hmm. Okay, now I know what I did wrong.
All right, and then you said 22.
Yes.
Okay, 7.6 number 22. And that says solve the equation. So we've got 3/5 plus 7 over x plus 2 equals 2. So I'm going to clear the fractions by multiplying both sides by the LCD, which is 5 times the quantity x plus 2. Are you okay with that?
Yes.
All right, so we've got 5 times x plus 2, and over here, 5 times x plus 2. So distributing 5 times x plus 2 times 3/5 plus 5 times x plus 2 times 7 over x plus 2 equals, see, 2 times 5 would be 10. So I'm going to write 10 times x plus 5. You okay with where I got the 10?
Yes.
All right. Going across and reducing, those go away. And I have 3x plus 6. Okay. Plus, those go away. And I have 35 equals 10x plus 50.
Wait,
Combining,
why did you write x plus 5?
we're at
On the top, you wrote 2 times 5 and then x plus 5. It isn't supposed to be x plus 2?
yes, it is. Thank you so very much. Okay. That, yeah, is that the only place there? Yeah, okay. I'm glad you caught that before I went on. Okay, we good?
Yes.
Yes. Okay, combining like terms, 3x plus 41 equals 10x plus 20. I'm going to subtract 3x from both sides. 41 equals 7x plus 20. Subtract 20 from both sides. 21 equals 7x. Divide by 7x equals 3. And as long as x isn't negative 2, we're okay, because if it was negative 2, that would be undefined. You okay with that one?
Yes. I had most trouble on where you did like the 2 times the 5 and the x plus 2. I didn't know if I had to multiply it first, like 2 times 5 to get the 10, and then the rest, or just all together, flat out, like 10, 2x plus 2 kind of thing.
Yeah, because you multiply from left to right, so you take 2 times 5 is 10,
Yeah.
and then you would distribute the 10.
Oh, see, I kept trying to multiply the 2 times the x times the 2 on top of that.
Yeah,
Across.
I get it. Okay, number 26.
Yes.
Solve the equation. Y plus 2/3 equals 2y minus 12 over 3y minus 9. Okay. And here, if I factor the right-hand side of the equation, I get 3 times y minus 3. Okay, like that.
Yes.
And there's also an implied 1 there. So my denominators are 1, 3, and then 3 times y minus 3. So my least common denominator is going to be 3 times y minus 3. You okay
So
with
for
that?
this one, I started it off by just subtracting 2/3 from that equation to get y equals. Can I still do it that way, or
You can. What did you do then?
once I did that, I did the 3y minus 3 as the least common denominator.
Mm-hmm.
And then I kept solving out, crossing out, and then I got y equals 2y minus 12 minus 2y plus 6. And then take out the common, I got y equals -6.
Okay, let's do this. Let's follow what you did and see if we can find out what happened. So
Okay.
go ahead, what?
I subtracted 2/3 to get
Yeah.
y alone.
Right. Well, now technically y isn't alone because there's still y on the right side.
Yes.
But okay, so then you've got,
And then I have I took out the greatest common factor from both of that first problem, I guess. So it'd be 2 and then y minus 6. And then the 3y minus 3 stays the same.
oh, you factored the numerator.
Yes.
Okay. Okay.
And then from there, then that's when I put the least common denominator, which is the 3y minus 3. And I
You did what
multiplied
with
it to
it?
both of those.
So you multiplied both sides by that?
Yes.
Okay. So 3y minus 3, 3y minus 3. Okay.
That's where I got it wrong. I didn't multiply the other side.
Ah. Okay. Okay. All right. So I'm going to go back now and finish this up the other way. You okay with that?
Yes, that's
Yeah.
fine.
So because you saw why that went wrong. I mean, I think you could have done it that way ultimately, but it probably would have been more work. So right here, let's do the 3 times y minus 3, 3 times y minus 3. Okay. So let's see here. This is going to be 3 times y minus 3 times y plus 3 times y minus 3 times 2/3 equals 2y minus 12. Okay.
Yep.
I'm going to rearrange this and put the y over there. So 3y times y minus 3 becomes 3y squared minus 9y. You okay with that?
Yes.
Plus, I can reduce out those 3's and have 2y minus 6. Okay with that?
Yes.
And then on the right side, combining like terms on the left, I get 3y squared minus 7y minus 6 equals 2y minus 12. It's a second degree equation, so I'm going to put everything on the left side set equal to 0 on the right side. 3y squared minus 9y plus 6 equals 0. Okay. I'm going to factor a 3 out of the left-hand side, giving me 3 times y squared minus 3y plus 2 equals 0. I'm going to factor the trinomial. Let's see, y minus 2, y minus 1 equals 0. So y equals 2, y equals 1. And it says enter your answers as a comma-separated list. So 1, 2. All righty.
Okay.
And I think that was all your questions there, right?
I think the other ones are just like these ones. So I think I can figure the other two
Yeah,
out.
well, and all the other ones you've got right. So, okay, so now let's go on to section 7.7. And first of all, I want to look at some tables. So I'm going to draw the tables out here. I'm using a ruler in case you think I can draw that straight of a line. I can't. And then let's see. That. That. And okay. So this is a snowmobile. And this is a 4x4 truck. And we've got D equals R times T. And this is a 4, this is a 3, this is an R, and this is an R minus 5. Okay, so we've got the formula D equals RT, distance equals rate times time, okay? And we've got a snowmobile that travels a distance of 4 miles, it doesn't say that, but anyway, at a speed that's R. We've got a 4x4 truck that travels 3 miles at a speed that's R minus 5. What we're going to do is we're going to fill in the missing boxes, the time, but we're going to write them in terms of what we already know. And this is just to get us ready for some problems we're going to be doing here shortly. So if D equals R times T, if we wanted to solve for T, we would divide both sides by R, right? So time equals distance divided by rate. Do you see that?
Yes.
So we're going to take this relationship and we're going to say, okay, if time equals distance divided by rate, then the snowmobile time would be 4 divided by R, distance divided by rate, and the 4x4 truck would be 3 divided by R minus 5. Okay? You all right with that?
I believe so.
Got any questions there?
No.
Okay, that's the whole point of doing that problem. We're going to look at another table now. And here we go. Whoops. Okay, so I can draw straight lines with a ruler, but not parallel lines, apparently. Okay, here. And let's see, I need 1, 2, 3, 4. So 1, 2, 3, 4. Got city, savings, bank, and credit union. We're going to say that I equals P times R times T. This is 50. This is 75. This is R. This is R minus 0.02. And this is 1, and this is 1. Okay, so I equals PRT. Interest equals principal times rate times time. Simple interest formula. We need to fill in for P. So if I equals PRT, to solve for P, we would divide both sides by RT. So P equals I divided by RT. Are you okay with that?
Yes.
So P equals I divided by RT. So P equals 50 divided by RT, which would be 1 times R, or just R. Okay. In the bottom, we'd have 75 divided by R minus 0.02 times 1, which is R minus 0.02. All right. So all we're doing is we're writing one variable in terms of the other information given.
And it's 0.02, right?
Yes. Yeah, R minus 0.02. I should have made my boxes bigger, but I didn't. Sorry. You okay with that?
Yes.
All right. Next, how would you write 9% as a decimal? 0.09. how would you write 0.035 as a percent? 3.5%. So to convert from a percent to a decimal, you move it 2 places to the left, drop the percent sign. To move it from a decimal to a percent, 2 places to the right, and add a percent sign. Do you remember that?
Yes.
Okay. Those are the warm-up exercises. Now let's get to the actual problems. Here we go. If a number is added to the numerator of 5/7 and twice as much is subtracted from the denominator, the result is 8. Find the number. Okay, find the number. I'm going to call it X, okay? If a number is added to the numerator of 5/7, so we have 5/7, and we're going to add X to the numerator, all right? If a number is added to the numerator of 5/7 and twice as much is subtracted from the denominator, the result is 8. Do you see how I got that equation?
Yes.
All right. So now we're going to solve for X. This is an equation with a fraction. The LCD is going to be 7 minus 2X. So on the left side of the equation, the 7 minus 2X is reduced down, giving me 5 plus X. And on the right side, I get 56 minus 16X. Any questions there?
Nope.
I'm going to solve for X on the left. So I'm going to add 16X to both sides. I get 17X plus 5 equals 56. I will subtract 5 from both sides. 17X equals 51. Divide by 17 and X equals 3. So the number is 3. Let's check it. 5 plus 3 over 7 minus 2 times 3 would be 8 over 1, which is 8. So it checks. Okay with that?
Yes.
All right. New situation. Fast cars. The top speed of a Dodge Charger SRT8 is 33 miles per hour less than the top speed of a Chevrolet Corvette Z06. At their top speeds, a Corvette can travel 6 miles in the same time that a Charger can travel 5 miles. Find the top speed of each car. All right, so we've got speed, distance, and time. Speed is also known as rate. So distance equals rate times time. That's that formula from before, okay? Okay. And so distance equals rate times time. And we've got the Dodge and the Chevy, okay? Dodge, Chevy. Okay. Any questions about what I've done so far?
Nope.
Okay. All right. The top speed of a Dodge Charger is 33 miles per hour less than the top speed of a Chevy Corvette. So the Dodge's speed is 33 miles an hour less than the Chevy. So if we call the Chevy R, the Dodge would be R minus 33, because the Dodge is 33 miles an hour less than the Chevy. All right? Any questions about that?
Nope.
At their top speeds, a Corvette, which is the Chevy, can travel 6 miles in the same time that the Dodge Charger travels 5. So this is going to be 6 miles, and this is going to be 5 miles. Okay? Any questions on that?
Nope.
Now, let me read the story once more. The top speed of a Dodge Charger is 33 miles per hour less than the top speed of a Chevy Corvette. At their top speeds, a Corvette can travel 6 miles in the same time that a Charger can travel 5 miles. Find the top speed of each car. Do we know anything about the times?
Wouldn't it be just one since they're the same?
Okay. They are the same. So they wouldn't be 1, they would be equal.
Okay.
You following that?
Think so.
All right, I'm just going to put a little sideways equal sign here for the moment. Now, so the time of one is equal to the time of the other. Well, distance equals rate times time. Therefore, time equals distance divided by rate. Remember, we did that earlier in a problem, on a table.
Yes.
So the time of the Dodge would be 5 divided by R minus 33. The time of the Chevy would be 6 over R. But what do we know about the times? We know that 5 divided by R minus 33 equals 6 over R. Since the times are equal, now we've got an equation with just one variable. So do you see how we use the fact that the times were equal to set up this equation?
Yes.
All right, so let's solve this equation. The LCD is going to be R times R minus 33. So R times R minus 33, R times R minus 33. On the left side, we'll reduce out the R minus 33s and have 5R. On the right side, we'll reduce out the R's and have 6R minus 198. 180 plus 18. All right.
Yes. I was writing, sorry.
No, that's fine. I'm just waiting for you. Okay, let's solve for R on the left. I'll subtract 6R. So I get negative R equals negative 198. Divide by negative 1, R equals 198. So the Chevy is R, which is 198 miles per hour. The Dodge is R minus 33. Let's see, 198 minus 33 would be 65, I believe. Okay with that?
Yep.
All righty. Let's go on to another problem. It says boating. A boat that travels 18 miles per hour in still water can travel 22 miles per hour, downstream in the same time as it takes to travel 14 miles upstream. Find the speed of the current in the river. Okay, so we've got miles per hour, that's rate. We've got miles, that's distance, and we've got time. So this is another distance equals rate times time problem. Okay. And let's see here. All right, so distance equals rate times time, or D equals RT. Okay. All right, now let's talk about current. The best example I can think of is, have you ever ridden an escalator?
Yes.
Okay, so if you get, let's say there's an escalator that is traveling at a rate of 3 miles per hour. Okay, so if you step onto the escalator and just stand there, you will be moving 3 miles per hour, right?
Hmm.
Okay, what if you're impatient? You're in a hurry. You get on the escalator and you walk up the escalator so that you are moving up the escalator 2 miles per hour. How fast are you actually moving now?
5 miles.
Right, 3 for the escalator plus 2, 5 miles per hour, right?
Hmm.
Okay. Now you're going to be a naughty kid and you're going to go the wrong way on the escalator. Have you ever done that?
Yes.
Me too. Me too. Hopefully not recently, but well, that's okay. All right. So now you're on the escalator and but you get up at the top and it's going against you. But now you get on and you start walking 2 miles an hour. What's going to happen?
Pretty much not going to be moving. It's kind of
Yeah,
staying.
why not?
Because you're kind of going against the 3 miles and you're only going 2, so you're
Right, right. Okay.
stronger than.
So my point is this. If you're going with the escalator, with the current, with the wind, it's going to be the speed of that wind or escalator or current plus your speed, right?
Mhm.
If you're going against it, it's going to be that current or speed or wind or whatever minus you. Does that make sense?
Yes.
Okay. Now, let's see here. A boat is traveling 18 miles per hour a boat that travels 18 miles per hour in still water can travel 22 miles per hour downstream. Okay, so we've got downstream, and it's going to go 22 miles, okay, in the same time as it takes to travel 14 miles upstream. Okay. Any questions where I got the parts of the table that I filled in?
No.
What do we know about the times?
The same time.
Okay. Now, we know that the boat can travel 18 miles per hour in still water. Okay. So that would be like saying your average walking speed is 3 miles an hour and you're on the escalator kind of thing. In other words, the boat is capable of 18 miles per hour without current helping it or current hurting it. Okay. We're supposed to find the speed of the current. Let's do this. Speed of current. How about if we let that equal R? All right. If I'm going downstream, is the current helping me or hurting me?
Helping.
So if I'm capable of 18 miles per hour, that boat is, plus I'm going downstream, my rate would be 18 plus the rate of the current, right?
Yes.
Going upstream, it'd be the 18 miles an hour minus the speed of the current. You okay with that?
Yep.
All right. Now, distance equals rate times time, divide by R, time equals distance divided by rate. So the first time would be 22 divided by 18 minus R. I'm sorry you can't see that because I didn't make my boxes big again. And the bottom one is 14 divided by 18 minus R. So I've got time equals distance divided by rate. See if I can do any better there of getting that in there. 22 divided by 18 plus R. So what is my equation? Since the times are equal, 22 divided by 18 plus R equals 14 divided by 18 minus R. You okay with that?
Yes.
So we did the same thing as the last problem in that we set the times equal. What's different here is that in the last problem, we had one of the cars traveled faster or slower than the other. So we had the rate of one car and then that rate minus 33. In this problem, we've got the current helping the speed and then hurting the speed. So it's a little bit different, but it's still distance equals rate times time. Okay? Our LCD is going to be 18 plus R times 18 minus R. So I'm going to have 18 plus R times 18 minus R and 18 plus R times 18 minus R. On the left side, those are going to reduce out, giving me 22 times 18 minus R. On the right side, those are going to reduce out, giving me 14 times 18 plus R. So far, so good?
Yes.
22 times 18 is 396 minus 22R equals 14 times 18 is 252 plus 14R. I'm going to solve for R on the right. So I'm going to add 22R to both sides. 396 equals 252 plus 36R. I'm going to subtract 252 from both sides. So what is that? 144 equals 36R. Divide by 36 and R equals, oh, what is that? 40? 144 divided by 36, yeah, 40. So R is 40. No, R isn't 40. What is R?
I was going to say that kind of looks wrong.
Yeah,
4.
sure does. R is 4. Now, does it look right?
Yes.
You know why I knew 40 was wrong? Because I looked at that and I said, wow, they're never going upstream. If they're going 18 against a 40-mile-an-hour current, it's not going upstream. So I was off by a factor of 10. Okay, so R is 4. So then what did it say? It said, find the speed of the current. Well, that is the speed. So the current is 4 miles per hour because R was the speed of the current. Okay? You good to go or still working on that one?
Good to go.
All right, one more before we set you free. This says comparing investments. Okay, it says an amount of money invested for 1 year in a savings account will earn $1,500. That same amount of money invested in a mini mall development will earn $6,500 interest in a year because the interest paid is 10% more than that paid by the savings account. Find the rate of interest paid by each investment. Okay, so what do we have? We've got the time, which is 1 year. We've got the amount of money, that's the principal. We've got the interest, that's the $1,500 and the $6,500, and the interest rate 10% more than the other. So I equals PRT. So do you see that this is I equals PRT, not distance equals rate times time?
Yes.
Okay, that's the first thing we've got to get. All right, so we've got a savings account and a mini mall. Okay, that's our two investments. an amount of money invested for 1 year in a savings account, so the time is 1 year, will earn $1,500, so that's the interest. Okay, so an amount of money invested for 1 year's time makes $1,500 interest. That same amount of money invested in a mini mall development will earn $6,500 interest in 1 year. So the time is a year, the mini mall's interest is $6,500. It said that same amount of money. So what does that tell us about the principles?
That's the same.
That they're equal, right? That's just my sideways equal sign. All right, what do we know about the rate? We know that, let's see, this same amount of money invested in a mini mall development will earn $6,500 interest in a year because the interest paid is 10% more than that paid by the savings account. So if the savings account interest is R, the mini mall would be R plus, and that's 10% written as a decimal, 0.10. And I could have written just 0.1. I didn't need that 0 at the end, but I just wanted to emphasize it was 10%. Okay.
Okay.
All right, now, if I equals PRT, and we're trying to solve for P, we'll divide both sides by RT. So P equals I divided by RT, which again is something we did way back at the beginning of this lesson today. So P is going to be 1,500 divided by R times 1, or just R. And the second one, it's going to be 6,500 divided by 1 times R plus 0.10. And again, I've written them so small, but here's what I've got. I've got 1,500 divided by R equals 6,500 divided by R plus 0.10. Okay? So do you see, in each case, I'm solving for the variable that's the same in both situations, solving for it in terms of everything else that we're given.
Yes.
So now my LCD is going to be R times R plus 0.10, R times R plus 0.10. On the left, the R's cross out, and I've got 1,500 times R plus 0.10. On the right, the R plus 0.10s cross out, and I've got 6,500 R. Again, so far so good?
Yes.
Distributing, I get 1,500 R plus 150. 1,500 times 0.10 would be 150. And that equals 6,500 R. We'll put some commas in there. I'm going to subtract 1,500 R from both sides. 150 equals what? 5,000 R. Okay with that?
Yes.
Divide both sides by 5,000. R equals, let's see, if I take 150 divided by 5,000, I get 0.03, which would be 3%, right?
Yes.
So the savings account rate would be 3%. The mini mall would be 13% because it's 3% plus 10%. Okay with that?
Yep.
All righty. So your homework, you've got this section, 7.7, and the chapter review. Tomorrow, we'll review for the chapter 7 test on Thursday. I will be back at 1:15 with an office hour. If you have any questions, I'll stop the recording.